Hello, and welcome to my report on Lab 2, Further Tape Experiments. This week's lab asked us to validate our data from Lab 1 and create an updated computational model for two charged strips of tape with one floating above the other. Here, we can see my data from Lab 1. The length of the tape was 27 centimeters, which worked out to be 0.27 grams, using the ratio provided in Lab 1. Using the mass, we can calculate the force due to gravity to be 2.65 times 10 to the minus 3 newtons in the negative y direction. From Newton's third law, we know that the electric force has the same magnitude in the positive y. Lastly, the distance at which I held the tape was 0.6 centimeters underneath the top tape. However, during the coding process, I had some trouble getting the force due to gravity and the electric force to be equal in the model. I went back and verified some of these data. Firstly, I weighed a piece of tape which was 27 centimeters long, and it was actually 0.19 grams, not 0.27. This obviously changes the force due to gravity. The other thing which had to be changed was the charge on the tapes, as the electric force was calculated to be less than the force due to gravity. Now we're going to look at the coding process and the computational model. In Lab 1, we modelled the two charged tapes as point charges, one placed above the other and held in place as the gravitational and electric forces resulted in no net force, being equal but in opposite directions. In this lab, however, we are looking to model the tapes not as a single point charge, but instead as many point charges, each with an equal portion of the total charge. To begin the coding process for the computational model, we would set the initial conditions. In this case, that was the observed values from Lab 1. We then included the function we wrote in Lab 0 to calculate the electric field at a point. This function takes a charged particle and an observation location as parameters, and uses the past information to record Q, R, the magnitude of R, and the direction of R, and uses these values to calculate the electric field at the observation location due to the charged particle using the electric field formula. We were given a function for generating line charges. We use this function to make two charged strips. To do so, we can edit some of the important parameters, like the position and the number of point charges used to model the tape. For the purposes of this demonstration, I'll use 50 point charges. We then iterate through all the point charges of the top and bottom tapes. For every point charge in the top tape, we go through every charge in the bottom tape and calculate the electric field at that location. We keep track of the net electric field at each location of a point charge in the top tape, and then multiply it by the amount of charge on one of the point charges. This gives us the electric force due to the bottom tape at each section of the top tape. We draw an arrow to represent it and keep track so that we can superpose them to get a single net electric force applied to the top tape. We lastly draw an arrow representing the net electric force and an arrow representing the force due to gravity. This is the output of that model with 50 point charges. We can see that the force due to gravity and the electric force are nearly equal. This brings us to the final questions. The first of which asks us what would happen if we modelled our tapes as single point charges. When we compare our value for the charge from Lab 1 with the value for the charge from Lab 2, we can see that the charge from Lab 2 is much greater. The following question asks us why we think these values are different. This is because in the second model, there are many components of the electric force acting in the x direction, where the model from Lab 1 expects all electric forces to be acting in the y direction. However, in the second model, we still see that the net force only acts in the y direction, and this is due to the symmetry of the object and the components of the electric force in the x direction being equal in both directions and therefore cancelling out. Thank you very much for listening.